Maybe there might be a bonus one that I don't circle, right? Yeah. Okay. All right. So the handouts that you should have in front of you, or that you should work on, are the ones where, let's call it, it doesn't have a name to it. Mine says Stat 345, but yours is not Stat 345. It'll say Show All Work and talks about the industrial designer. Yes? Huh? Okay. You don't have it, it's in the back. Yeah. Remember, it's the industrial designer wants to determine the average number of things. Yes? We might not have done them, but you should know how to construct a confidence interval and everything else. All right? So those problems you should work on. All right?
All the ones on here?
I recommend A, B, and 1, A, B, and C, and probably number 1 and number 3 on the back page. Okay? Say like, confidence interval solutions, even though I didn't give you the solutions. All right? All right? Okay, next sheet. It says, I have here Sammy Review, and it says Sample Proportion Examples. Sound familiar? Bless you. You don't need this one. This one says, according to a 2009 current population survey. Yes? Ryan's on the ball. According to, it has, if I didn't hand it out, it's probably over there, and it's ready to rock. Okay? That shows you how to do the population proportions, Mr. Upper.
What does the front of it look like?
The front of it looks like this, even though mine's the Sammy Review. Okay? You should have all of those. They're in the back. Staple them. And I have an extra stapler right here. Okay? I will put the formulas on the board. Okay? Okay? So, in fact, all of them are right here. They're all answered for you, right? Yeah? Okay. The next one of interest, let's call this the Cambridge one. It was a single sheet. It had 9 problems. I know I'm asking a lot. I'm going to go through it today.
I just have the answers for that.
Yes, you do only have the. I have the front page and the back page. It should be back forth.
What was the one before that?
The one before that says for me Sammy Review, sample proportions. It shows the problems all worked out. I need to get that. Wait, look at her. Ooh, okay. All right. All right, moving on to the Cambridge one. I have the Cambridge one here. Look familiar? I'm going to tell you which ones of interest that I like. Okay? That you should. It's like, listen here. All right? I really would know how to do number 1. And I'm going to show you how to do number 1. Okay? Okay.
The last 2
I did. Don't worry, we're going to go over as much as we can today. Remember, there's only 5 problems that I have on the test. Yes, it's not that tough. Yes, Kate.
extra Cambridge ones?
Extra which one?
The Cambridge one.
It's not in the back?
Do you want to take a photo of this?
It's in the back. It should be in the back. If not, I'll have copies
It just has
today.
the answers in the back.
Do
you want to take a photo of
It's
this?
a back forth. Okay, so Cambridge, number 1.
Yep.
Ready? Number 2. I do like that fat burger. I call it the fat burger one. Number 3. Oh, definitely. I love number 5. Okay? And you already have the answers, okay?
Yeah.
You don't have number 5 in a survey?
It doesn't say number 5, but it's like it comes right before number 6.
It's number 5.
The numbering got cut off.
Hold on. Go ahead. So that's number 5. It says in a survey of 1,000. Okay?
Yeah.
And then number 9. Say that. You okay?
Yeah.
All right.
The last one.
Sophia. But thanks for the college hit, right?
For this one, the Sammy Review, is it all of them?
It can be because I gave all the answers. What I would recommend is just know how to do the fortune cookie one and the survey. And you'll be fine. Remember, I have to give you the formulas, okay?
Nick, did you see this?
And then finally, I believe that I'm not sure if I passed these notes out. They're in the back. It says confidence interval for proportions. I definitely know they're in the back. And it has more wonderful work and everything else.
Back of what?
It says this one right here. It says confidence intervals.
Okay. What is it?
It might be in the back where Captain Cadet is. Okay? Yep, look. Maybe I'll pass them out for you, okay? It says confidence interval and so on. Oh, hello there. Go ahead.
Hi.
I'll get them for you. Oh, and pass this around. Can you identify where I am? And you just have to tell me the.
The one with the
Yeah,
glasses.
you're doing fine. That's the one. Okay. They're not all mixed up. Yeah.
Sophia, did you see this?
So which worksheet does this correspond to?
I think that's its own thing. Because it gives you the answers.
So it wasn't anything that we were supposed to work out.
No. This is new for today.
But we don't have an answer sheet for this.
Okay, I'm going to pass them out for you, okay? So this is the confidence interval.
Yeah, I just asked him about it. I don't even remember.
I think you passed that one.
I probably did. That's okay. That's why I have always look in the back.
I think I have.
You got that one?
Mm-hmm.
Eileen? Huh? Confidence interval thing? Yeah, you're good.
What page of it is the...
Okay.
I did not get that.
Hopefully it's going to be introduction. You think you got it? Are you sure? Michael?
What is what?
He has it.
Oh, Murmer. You didn't see it? Which one's Murmer?
You'll tell me. Just give it a ring. Okay. Oops, sorry. Yeah? Got it? Don't got it. Remember, you always check in the back, right? You're always going to have that in college. I don't like. I know this is a statistics class, but we want to be more than probable.
The probability that I have.
All right? You got it? All right.
0%.
Now,
Mr. Murmer.
that's it.
So, like, would you be able to go over
I
number
will.
9 on the
I will.
Cambridge?
I'm going to go over as much as I can today. Guys, I only can ask 5 questions. I want to get you, you're going to thank me later if you ever take a statistics class, mathematics class, or anything above the Rockledge world, okay? I guess I should forego the video. I will. Okay. It's only 4 minutes, but I got to turn the light up. I got to turn something. All right, light on, please.
Mr. Murmer?
That's me. Confidence intervals. I'll show you. Okay. I'll tell you. All right. Yeah. Pass it around. Did you find out where I am?
Yeah.
Everybody see it?
Yeah.
Yeah. That's me.
The one with the hair.
Yeah. The one with the hair. Yeah. Okay. So I did play sports. Okay. Okay. This is one of them. This is actually like number 1 right here. I have to get this formula to you. Don't worry, I'll have formulas on there, right? You'll be fine. You will. Big statement, okay? For things you got to know. I got to know how to do confidence intervals and the formulas thereof, how to do the confidence intervals, and explain to me 1 or 2 sentences what it means. What does that confidence interval mean? Listed as a range, everything else. Ryan.
Oh.
I'm going to get to this in a second, okay? I'm going to answer, or I will, okay? I'm going to do the big thing. Next big thing is sample proportions. Follows the confidence interval as well. You know, you have to use another formula. You got to figure out the proportion, x over n, and then you do the formula for standard error. Remember, PQ, square root of PQ over n. Remember? I'll put that on the board. Didn't I do notes on this stuff and everything else? Oh, yeah. Oh, yeah.
I think so, yeah.
Yes.
I know how to do confidence interval in this.
With the mean, right, with the x bar, and the other one was the sample proportion. Here's the confidence interval. Yes? Do you have notes on all those? Yes. Do you have problems on those that have solutions? Yes. Do you have Cambridge ones? Yes. Do you want my overwhelming you? Probably.
Mine's actually a little much.
I know it is, but there's just so much to cover. I always want to say to myself, you know what, I did it. Everything I could do other than take the test. And yes, Sam's back. Yay! He's going to introduce himself tomorrow. I'm not going to bring him in, okay? 4 days he was out gallivanting, all right? All right. This one here is another one that you need to know how to do. This is number 1 on the Cambridge.
Okay.
All right? This is very similar how to do number 1. All right? And it has the answers over there, doesn't it?
Yeah.
All of the
Yeah.
answers are there, even for number 1 that's on Cambridge. This is an example for number 1, how to do it. So that means, Emily's like, "Did you give us this formula?" Sure, I will. I'll give you formula. I'm not giving anything away, am I? No. But I'll give you the formula. All right. This is s squared because that's what the books denounce it as. But it's s squared is similar to sigma, small case sigma. because of the size of n, okay? Now, it's an unbiased estimate, so if you see the word unbiased estimate, whoop, this is S squared, so S squared is what?
Variance.
Say it again.
Variance.
Variance.
Thank you. Variance. I know it's period 1, 2, right? So variance. So if it asks for the mean and variance, boom. And then, I might just throw in standard deviation in there as well, right? So it gives you some data, whatever it is, right? A whole bunch of numbers and so on. Instead of doing, this is very similar to this guy right here, right, for the variance, right? What we're going to do is we're going to use this formula right so there's how many things here? 1, 2, 3, 4, 5, 6, 7, 8. 9. So n equals 9. All right. So we got 9, and we put 9 in here to get, obviously, the mean. Add them all up, divide by 9, boom, you get 58. Okay? I just did this in my head, of course, right? Yeah. Mr. Epler.
So I used a different formula, but I came to the same answer.
That's fine. That's okay. Right? Now, we're going to subtract 1 from this one, because it says it in the book as well. I'm always debating about it, but if I give this formula, you got to use it if I ask for an unbiased estimate. The reason why it's an unbiased estimate, Emily, is because, well, we're really subtracting, which arguably is there might be another associated mean as a bimodal in here. So that's why we take it away and make it more, less of a variance. So that's what's called unbiased estimate. So you got all these things here and so on. You get the mean, you get 58. Okay. So now it says, give me the unbiased average or mean, and then it wants the variance. 1 over 9 minus 1, because n is 9. You take the sum of the squares of all the data, whatever they are. 1, 2, 3. Square them up individually and add the sum of the squares. Boom, 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 boom. Right? Subtract just what? Well, this is how you have to say it. The sum of their not sum of their squares, but what? Just the sum squared divided by n. Say it again. A lot of people mess this up. They get these like, well, that's the same thing as this. No, it's not. No, it's not. This says I square those individual pieces of data up and then add them. This says I do the summation first, square it, and divide by the number of choices.
Wait, would that
Yes?
mean that your square on top of n would be on the outside of the parentheses?
Yeah.
Say that again, please. Show me.
Would
So-
that mean that's on the outside?
I gotta look. Yeah, I think you're right.
Yeah,
Yes, it is. It is. I wrote it real fast
Okay, there we go.
before I went to my ethics debate next door. Okay. All right. Yes, it is. I was going to check it. Don't worry. I'm going to check all this up as well. All right. So you got this guy and this guy. You get for a variance of 34.25, 34.3. All right. Now, if it says, hey, I also want the standard deviation, you take the square root of that decimal. And you get the answer to the nearest 10th of 100. That's it. That's it. You should be able to do number 1 with ease. With ease. I'm waiting for
That's
questions.
number 1 on Cambridge.
Or it's like, let's say it's number 1 on Cambridge, right?
It's the same format, right?
Yeah, it's
Not the
same
exact
format,
same
it's not
numbers.
the same numbers.
Right? All right. No questions about this. Yes, Mr. Epler.
So when I did the x minus x bar, the sum of x minus x bar squared over n minus 1.
That's fine. And I should put n minus 1 here. I wrote the formula real fast. I had to run over those.
So there's another way to do it.
Yeah, that's the same thing. Yeah.
Yeah, this is. I prefer if you use that way, but that's fine. If you show me how you got it, I'm going to give you the formula, right? You can manipulate the formula any way you wish, as long as you do it mathematically. Okay? Now, you okay with this? Now, you notice that on number 1 or whatever it is, right? It says 1A you take, for Cambridge. It gives you a whole bunch of data, right? A bunch of bottles or whatever it is, right? Yeah. And then you have to figure out the mean. Duh, I can do that sleeping. Then you figure out the standard deviation as well as the variance. Got it. Now the next thing it says is, okay, haters, 98% CI, right? That's what it wants. So that means you do what? You go x plus or minus, come on, talk to me.
The x plus or minus z times the square root of the...
That's where, is it square root? Yeah, or it's square root of sigma?
Yeah.
Square root of, or just sigma?
And-
Right, or it's sigma squared
Yeah.
over,
Yeah.
right?
Yeah.
Okay. So Remember, this is a 98%, right? Oh, I have the values that I put down here.
Yeah.
Okay? Except for like 85, I'm pretty confident Michael and company, everybody, all of us can look it up again. Okay? In the table. All right? You okay with that? And then when you're finished, you go, oh, the confidence intervals between that and that. Yes?
Yes.
Whatever it is. Now, the last thing is what? Well, man, you ask for everything. Of course I do. Because you have me as a teacher. The next thing is like, what does that mean?
That means
Besides you. Besides you. Okay.
The mean falls between those two values.
In what regards?
For 98% chance that it happens.
I am 98% confident, or we are 98% confident, that the mean falls between blah and blah. Don't say that all the data falls in there. I will not. I will look for things wrong on the test if you do that. Bella?
What do we have to do?
Oh, what? Oh, I got people's attention.
Okay, so it's essentially what you're saying is the confidence interval is saying that 95, 98, 97, whatever percentage, that's the chance that the mean will fall between those two numbers.
For another data set, for another sample out of the entire data set. Yes.
98% X bar is going to be between it, right? And then the tails are what? 0.01, 0.01, right?
If you take another sample of the same overall group.
Using the 98% confidence interval, right? Remember, these are outliers. The mean can fall there, but we are 98% confident that that sucker's in between this value and that value. Game over. Tracking?
Yep.
Guess okay. I put my, anybody Greek? No one's Greek in this. You're Greek.
I like Greek food.
Oh, okay. That works.
I have a Greek
We
friend.
should. I lived in Greece for a little while, and then I visited. Yeah. I have a picture of me of the Parthenon. I have to find it if you want it. Like, and no, I wasn't there when the Parthenon was built. Okay.
Dang it.
You were there before it was built.
Ooh.
Oh.
Circular logic. Right? I can die, but you know, there was a show called Forever, and he dies and so on. Oop, if you ever saw it, I didn't think so, but you get the idea. Then he's born back in water. Shot myself.
I'm swinging it around to drool.
Drew blew up, yeah. All right, everybody okay with this news thing?
Yeah.
No big deal. Now you could have done this, right? Well, get the mean and go 58 minus 49 squared. Oh man, you're going to be there forever, right?
Yeah.
This is a fast food way of doing it. Okay? Got it?
Oh, that's why you should use that way instead of my way, because my way was like took forever.
You'd be there forever.
Yeah.
And I'm going to go, give me your test. Right?
So we'll be working on it after we graduate.
Yeah. What's the purpose? Who would think of this crazy stuff? Besides Sam, right? No, I guess I had this dry cleaned, and now the dry cleaner's going to write marker again. Yeah. Okay. Any questions? Pretty good?
Yep.
So you know what you have to do.
It's another
Yeah.
practice.
I gave you so much that you like the test is there. It's there. I'm 99.999% confident that all my questions are in that batch of insanity. Yes, sir.
Another question. What do you think the next time the Giants will win?
Ooh, this is not good to bring this up, right? Yes, especially during test time, right? But yes, they better win next week against the hapless Niners. Yes, absolutely.
Oh, yeah.
Okay.
I mean, that's kind of a given.
So did I give you the ones that I thought were my greatest hits? Yes.
Yeah.
Didn't I tell you which ones I favored?
Mm-hmm.
Which ones were the good?
Okay, off the Cambridge, right? Because this is a Cambridge class. Yeah, I know.
1, 2, 3, and 5.
1, 2, 3, 5.
9.
I also like 9.
Okay, but we don't.
Because 9 talks about the sample, the number of things in the sample. And I have to put that formula up there too. Okay? And I usually, good, I love it. Yeah, that's right. Anything else? Oh, I can't put my hand behind my back. On Thursday, I find out. Yes, what's that one? The answers are in the back for those.
Wait, where's
For the
I was
Cambridge.
just waving it over.
That's
Not
okay.
reading that.
Caitlin?
What?
Well, I
Do you
don't
have an extra packet?
which one? Cambridge?
Cambridge one. That's
Okay,
what I
the
have.
back fourth? I should. All right. All right. So I guess that my spiel is finished. Yes, I do regular. Okay. Who does? So does everybody have what they need?
Yes.
I think so.
I do too. Anybody have any other questions for me to go over? Mr. Edwards.
Number 9 on the Cambridge.
Number 9 on the Cambridge. You want me to go over that one? Okay.
Can we try it first?
Yeah. Go ahead and try it first.
Wait,
Number 9 on Cambridge.
9, the last one?
Yeah, it talks about the number of people that from the sample size. They give you everything, and then they want to know, hey, so how many people did you, after all the data you collected, how much is, do you think you found a survey? And you're like, okay. And then you figure it out. Okay? She's like, yes, you can do it, trust me. I'm going to erase just this. And Sammy's back. He's meowing at my front door. Oh, I got a question for you. Let's see if you guys are really with me. Hey guys.
No, that's just notes.
Hey guys. Let's say I got a just for this data right here, just for fun. Let's say I got a confidence interval of 34. Let's say 53 and 59. 98. All of a sudden, somebody says, hey, you got a 61. They claim that they can get a 61, whatever the test is, using the same CI. Is it true?
No. Because it doesn't fall between those two numbers.
So, what is it? What am I really trying to say? Trying to help you out more than you think.
That there's a 2%.
Yes? Yeah, this is an outlier. This is ridiculous.
It's unlikely.
It's unlikely. Or if there's type 1, type 2 error, we got to talk about my favorite. I love proven liars and math. I love it. I love it. It's just amazing, the hypothesis test. I was just like, because the giant game sucks, so I couldn't stand it anymore because they got beat down the worst I've ever seen watching 30 years. I'll get off it. Okay, but, I looked into hypothesis testing, and you can prove some people's claims that they said, well, I can do that ESP thing, or we as a company believe that we can do make 61 milliliters of certain stuff in a certain container. And they can prove it to you and everything else, and then you back them up by statistics saying you're lying through your teeth. They make this type of claim. I claim I can do this. Well, statistically, you're lying through your teeth. Okay, that's what hypothesis testing is. Yes.
They should trade Odell for like a second round pick. Might as well recreate the team.
I think they should trade Eli to the Jaguars and get a pick. Okay. That's what I think. So if you see something like that, you get your 98% confidence interval thing, and someone says they claim something. If it's in between the range,
Then
yes, that the company's right or whatever. If it's on the outliers of that, no way. Even if it's off by a 1/10, that it's not true. Okay. You could argue, say, well, if they use another confidence interval or higher confidence interval, then yes. Okay.
I prefer Odell over Eli.
You prefer whom?
I prefer Odell over Eli.
Of course you do. Everybody wants the flash. And games are won by the offensive line. All right. Everybody okay?
Can you do it?
Can I do what?
Number 9.
Lady asked for number 9. I'll try. Let's see. I gotta find my stuff now. I have it here somewhere.
Do you want to use my paper?
No. Oh yeah. Okay, sure. It's around here somewhere. Yeah. Can I use it? Just like
Yeah, sure.
Does it have back forth? Oh, I gotta use the formula, right? Okay. So number 9. Okay. It's okay if I erase some of this.
Yeah. It's on video.
It's on video. That's good enough. Oh, be careful. All right, so for number 9, right? And didn't I give the formula for it? It's under that confidence interval page, right? And I should have the, there we go. You have it here too. It says 35% of a random sample, right, of n students, okay? You don't know the number n, you don't know the number of students, right? Mm-hmm. And the next thing says you want to construct a 98% CI. Okay, got it. And given that the confidence interval was 0.57, 0.157 was the standard error, I believe, or whatever it is, find out what n is, right? Something to that effect? Yeah?
So the CI is the 1.8.
Well, yeah, we got to put all this data in here, right? I had my sheet. Now, to find out how to do the ends, okay, I had everything here, and then I got it all mixed up. I gave you a formula for it, didn't I? Of course I did.
The
Yes.
n equals z squared.
There we go. N equals
Z squared times p times q
over.
Margin of error squared.
What's more than that?
It's the,
Oh,
yeah.
okay.
Bet you that's margin of error. Isn't it? Now she has the answers, okay? So z squared was for a 98% confidence interval would be what?
For 98, it's 2.054.
2.05? 2. What's the CI for 98?
No, I mean, that was the z-score with 98.
Yeah, remember, you gotta look that up, right?
With the z-score.
Yeah, I want the
98 is 2.33.
2.33.
And then squared would be
I think this. What's p?
5.42.
Wait, how do you get the z-score? You look it up in the table, right?
Yeah, because it's at 98% probability, right?
But it's also on
I
this
didn't
packet.
I have for a z,
I got like 2.6.
I got 2.33.
I think I have something else.
I got 2.6 something.
Okay. I gave you, I'll put the z's on the test. Okay, so other than 85, I think.
2.54.
Yeah, that's what I was-
They're ridiculous, okay? I have 233, all right? We would do 254 if you want. So if you want to put 254 there, that's fine,
You're
233.
gonna get it.
That's
Now, what's
99.
p?
P
P,
is
what's p?
0.35.
Why is p 0.35?
Because that's our success.
Success. Times the fail,
1 minus that.
1 minus that, correct. Margin of error was the interval, right?
Yeah.
0.157 quantity squared. Now, Eileen, you got the answer sheet there somewhere.
So the width.
Look familiar? Is it right?
Wait,
Number 9?
for it. They put 2.326.
2.23. 2.236.
2.326.
Which is 3.5.
3.3. Fine. Yes, ma'am.
So the margin of error is the width of
Yes.
the confidence interval?
Yes.
Oh, that's always what it is?
Yeah, if they say whatever it is, yeah. Well, I didn't calculate it out, right? Remember I put that ME on top of it, that Z and all that other stuff that multiplies.
So do you always square them? Oh, wait, never mind.
Yes, on the bottom you square, right? Remember, guys, it's coming from this, right? X bar plus or minus C. Remember this?
Yeah.
Yeah, that's how they're getting it. I think they're doing something right here.
And we have this formula?
They're solving for N. Guess what?
We have that formula?
Yes, yes. I'll put on the board. Yes. This is your what? That's for your CI thing, right? And then also you use the same thing for the sample proportion, right? The only difference is you do this, right? And then N is solving for N for that equation. Okay?
Wait, so we do that after?
Remember, yeah. Remember, this is P square root of PQ over N. I'll put it on there. Don't worry.
But is that part of this problem, or is that just?
That's one right here. This one was sample proportion, right? So we use the P instead, right? Because it's P. It's like saying that you went out and then you took out of a thousand. You don't know the sample size, right? So, but I got 35% that said yay or nay, and you knew the confidence interval and the margin of error. Tell me how many you would survey to get that answer, right? You'd have the other data set except for N, the number of individuals you surveyed.
So I calculated that out. I got 50.1, and they got 200 for A. So, like, they had
This is
something.
50.1. I don't have the answer with me. I don't have the answer.
They had like.
They might have been using something. I don't know what Cambridge is doing. I have to take a look at it. Okay?
Yeah.
I don't have my sheet here. Z is 2.3. Why'd they do 4? It's PQ.
They're using a different formula.
Yeah, I got 50.1.
Did you square the z?
I didn't square the Z.
That's
Square the Z here.
I don't know if you can.
0.35, 0.6, 0.5. This is correct. But the only thing different is he got 50, right?
Yeah.
Now what they did is they multiplied by 4.
Where are they getting that from?
Because I think they multiplied by 4 because they said there was 2 standards of error from the equation 2. I don't know why they multiplied by 4.
Maybe they just want to throw a 4 in there. You know.
I
Yeah.
got 50.
I wouldn't have thrown a 4 in
Their
there.
answer was 200.
Everything else is perfect except for the 4.
Why is it
They just decided to multiply by 4 for something.
I can't answer why they're multiplying by 4. I don't know why they're multiplying by 4.
They had bad fish and chips. That's what happened.
Because it's English. It's English, right?
Yeah.
But this is the formula for them all. I don't know why they're multiplying by 4.
50.11?
Maybe because of the standard of error. I can't. It doesn't even say it. Okay. I don't know why. Everything else is perfect the way we're doing it. But maybe I'm reading number. Oh, I don't have number 9 with me right here. This is yours. Number
Yes,
9.
Thank you.
Number 9 says what? That's not it. I can't find it.
Do you want mine again?
Sure. I can't find it. It's in this mess.
I think they're over there.
I might have. Sure. Number 9 does say what? Yeah, this is right. She wrote this right, didn't it? Within 3 significant figures. But why would that be a 4? I can't answer it.
So would
I have to look at it a little later.
So would we have to put 200 or would we?
I put 50. That would be my
So
answer.
that
Yeah.
would be the right answer.
I would live with 50, but I don't know why I can't answer for them.
We can try
Oh,
working the problem.
wait. They squared everything.
But where'd they get the 2 then to make it 4?
I know.
Yeah.
It's-
Where'd they get the 4?
Why don't we
Right.
try
They got
doing
the
that
4
problem
from the 2.
in reverse? We,
No,
Yeah.
they didn't.
The
The
N
2
and
is squared by
P and
itself
Q.
and 4 is separate.
Yeah, the only thing I can think
Well,
of,
that's what they did was.
see, 3 significant figures is 3 standard deviations from the mean. Why wouldn't it have been 9? Why wouldn't it have been 6, right?
Oh, wait.
You see
Well,
that
where
too?
did they get the 2?
I don't know. I do not know where they got, this is the formula that I've learned since birth, and I don't know where they're putting that extra 4 right here.
What's this
They put a
formula?
4 right here.
Is there a Cambridge book maybe that explains it?
Yeah,
Right there.
yeah, there's a Cambridge one.
That's what, I can't answer that question. I know that that's the formula. I know that that's by heart the formula. I don't know what Cambridge is doing. I think that they're just increasing the error. And I'm looking over what I did, and where are they getting the 4?
I mean,
They got it
unless
from the 2, and I'm trying to figure out where they got that 2 from. I think it's the equation that they were using.
what do you mean they got from the 2?
They're-
Well, the
they're
2 was
gonna
the-
run
If you look at the answer sheet,
It says 2 times D times whatever.
I'm trying to figure out where the 2
but that gives you
is too.
0.157, so they're just showing that how to get to 1.5.
Everything else is the same. I can't.
I don't know.
I don't know where they're getting the 2 either.
They did 4
Yeah.
times.
Could just be an error.
Sure.
How many times did I mess up?
Well, Cambridge, yeah, it's, I just don't know where they're getting that error. I mean,
That has statistics, right? So
yeah, because I have another problem that talks about if you go on to like the stuff I gave you, like to learn statistics that we're supposed to, it talks about the Curdle Dairy Farm, and I did not use a 2 or a 4 anywhere. I used that formula, and I got the right answer.
can we do another one?
Yeah, we can do whatever you want. Which one do you want to
Can we do 5?
do? Number 5?
Books.
They're over there. I don't know. You can look at this book. I have Stats
How
2
do we
book.
screw with the Americans? I know, throw a 4 in there. Jolly good.
You can take a look there. I don't know where they're getting that 4. I really don't. That's erroneous to me. Okay, so you want us to go over number 5? Okay, let me go over here so I can read it.
Number 5, Cambridge.
These at the bottom.
5 Cambridge, right?
Yeah.
Okay, 5 Cambridge. Oh, is that the sample survey thing? Oh, okay,
Yep.
that's not bad. All right.
Editors.
5 Cambridge. All right, play the answer. So, a survey of 1,000 random adults, 605 use email, right?
Oh, I think it was.
Yeah. Is that the one you're
I
talking
think
about,
it's
number
the
5?
editor decides to use a table.
I'm sorry, say that again. Which one?
The editor decides to use a random table.
Is this Cambridge?
Yeah, it's on the other side.
Oh, don't worry about 4. 4 takes too long.
Oh, it's 6?
No, it's on the other side. See?
It's the very top.
It's on the very top.
The number got cut off.
Yeah, number got cut off. That's it. So in a survey of 1,000 people, 605 said we do this.